Welcome, ladies and gentlemen, back to DC1 for another packed update on where we are with the development of HX50. Let's start with the development of the airframe. So we're currently building Fuselage 5 and Fuselage 6. Now, one of the benefits of our vertically integrated strategy is that we're developing in parallel all of the production methods and processes at the same time as we're developing the design and the aircraft itself. And what that means is we get the opportunity to bake in a lot of the things that get fed back from production, fed back from tests that we carry out on early production specimens into the design before we freeze the production tooling. We're also being able to test out a range of modified production processes for the fuselage that reduce the amount of labor, increase the amount of parallel activities that we can do as we produce these fuselages by working on open tools as long as we possibly can before we bring the whole thing together to produce the structural modelage that you've all got used to seeing. Some of the other areas that we've been working on is the development of the general fit and finish. So we've done an awful lot of work on the cabin doors. All of the tooling approaches for the doors have now been tested. The laminating processes have been developed and tested. We looked extensively at different ways of manufacturing the foam cores before basically deciding that a better way of doing the doors would be to tool both sides and to do them in parts. So all of that work has been going on over the course of the last month, and the guys are currently working on the final production scheme for the doors. So I mentioned last month how the guys had been developing improved tooling strategies to produce optically perfect glazing in-house, both in acrylic and in polycarbonate for the impact resistant windows on the front of the aircraft. We're currently reworking those tools as we speak at the moment to accept the new brow line and to upgrade the surface finish across the full suite of glazing panels that we've got on the aircraft. So all of those things have been going on during the course of the month. When we first got to put the first few glazed panels on, the first couple of doors on, and the physical property that we've got here on the shop floor really started to take shape. We've kind of got used to looking at it here on the shop floor now, but I think you'll all appreciate when you look at it, everything that we said we would deliver in terms of the images that we've provided, the look and feel and quality of the product is being delivered, even on these crude early production demonstrator prototypes that we're producing here. The door itself, as I said, it opens slightly upwards because of the angle of the A-pillar, and so we have a gas spring installed from the root of the A-pillar up to the base of the door here, well out of the way of foot swing. So this is the first structurally representative HX50 tail boom. You'll notice that the surface finish is significantly better on this. So the tooling that we use for this is greatly improved over what we use for the modelage. The processing parameters for curing these are also now significantly refined and getting very close to production intent. And the laminate in there is actually the laminate that we showed you last month, where we've got plies of carbon on the outside, the honeycomb core in the center, and then plies on the interior. So let's talk about the GT50 engine. So we've very much entered an exciting new phase with the GT50 over the course of the last month. We're now in a position where the actual parts that are being produced for the actual test engine are underway now, and every few days or so there's another trickle of parts from downstairs down to Mark, and the guys are a massive push now to get the gas generator for the engine built. They've been on with the engine drivetrain for some time now, and that's all coming together really nicely. So one of the areas that has been a particular success over the course of the last month has been the development of our turbine blade casting processes. So great surface quality. We're burning the stuff out of the investment really nicely, and as soon as we've finished the update for you guys tonight, these things are going off to be chopped up, put under an electron microscope, have all the chemical analysis done on them, have them x-rayed, make sure they're void and defect free, And once we know that's the case, we'll be purchasing this equipment so we can do these in-house, but we'll also be producing the full batch of turbine blades to be able to produce the test turbine rotors. That's coming together really, really nicely. And as soon as we get the results back for these turbine blades, we'll be able to make the full batch of blades for the test engine. So really excited with that. So in addition to the compressor, the turbine disc, the turbine blades, I made you aware over the last couple of months that we've also released the combustor. And we've got the test combustor in production at the moment. So all of the materials for the remaining parts of the combustor fabrication arrived last week, and they've subsequently gone out to a customer that's doing some of the prototype pressing and spinning operations for us, so that we can just get the whole thing done a bit faster. So all of those materials are in stock. One of the things that we'll be doing on the prototype combustor to avoid waiting for a very expensive production machine is we'll actually be drilling the 2,500 holes, precision holes in the combustor that are needed to mix the air and the fuel directly on the 5-axis. So just before he went on holiday, Mark did some trials on the super alloy material here that we use to produce the combustor, to demonstrate that we can drill these holes in a reasonable time scale using conventional methods rather than needing to use the laser drilling for the combustor. So we've proven that out. So as soon as those things are rolled, we can assemble it and produce the first combustor. So with that coming together, we obviously have to put the facilities together to be able to test it. So the two first tests that we want to do on the GT50 engine, the first one is the starter generator unit, and that involves both the power electronics side and the mechanical side of the starter generator unit. I'll talk about that later. The next test is the first part of the gas generator, and that's the combustor, making sure that we can get the combustor to ignite, making sure that we can maintain stable combustion before we go and put that into the engine, because obviously dismantling and reassembling a whole turbine engine to tweak parameters on the combustor isn't a terribly efficient way of working. So what you can see on the slide there is we've developed a simplified combustion test rig. So that rig is just finishing off being designed at the moment, and then again, as the boys return from holiday over the next week or two, we'll be putting that through the production facility here at DC1 to get that built at the same time as the combustor. And providing all of these things stick to the schedule we're working to at the moment, then we're targeting a first run of the combustion system for GT50 in October, and that will be rapidly followed then by the full gas generator unit. So really pleased with the progress made by the engine team and how all of that's coming together. And the guys have been developing the starter generator, which includes both the mechanical hardware and the power management unit, as well as all the control algorithms, studiously as the engine has matured. And so one of the things that we've been doing over the course of the last month is just tuning the design of the starter generator to produce its power at ever so slightly lower speeds, which means slightly lower voltages, slightly higher currents, and adapting that to how the engine wants to run now that we've got the full detail of the engine available to us. Now, the clever bits of a gas turbine engine, the compressor, the turbine blades, the fancy castings, and that sort of thing, are only one part of it. What you've got to remember is our real task here is that we're developing an engineered product. We're developing something that has to be made, and something that has to be made to a price to make general aviation healthy again. And what you can see here in front of me now is essentially we've got a slightly earlier version of the engine drivetrain, but we've got a full engine drivetrain, including the power takeoff from the power turbine, the speed reduction gearbox, the lay shaft that is essentially part of your tail rotor drive shaft. You've got the integrated torque sensors built into the drive shaft on the bottom, and then we've got the bevel gearbox at the front that allows us to bury the whole engine deep inside the back of HX50, out of the way of the wind, in the lowest possible drag installation we can. So we're now in a position where we're producing the first 3 drivetrains, and the final of those ones will be the test drivetrain and the first flight drivetrain. And we've also now produced the very first demonstrator Sprague clutch as well. So the housing, all of the interfaces that go into the drivetrain, ready for the machines for the end of the year. So this is the outer housing that plugs into our gearbox. Sorry, this is the drive shaft that plugs into the gearbox, and this is the output housing here. And as you can see, the shaft is free to run in one direction and lock solid in the other. The next area I'll update you on is the DigiCockpit. So as I mentioned previously, we've now got the system operating on target hardware. Since then, we've managed to get the target hardware driving the target screen via the correct communications protocol. So one new area of the UI development that's received a lot of attention over the course of this month. So the original concept for this looked quite nice, but the menu structure was a little bit clunky. And so one of the things that the guys have been investigating over the course of the last month is whether they can reduce all of that down to a simplified menu structure with a single home screen. And one of the things that we've been prototyping over the course of the last week is the first of the, well, it's one of the trim options and the first of the surfaces that we're going to integrate the puck into the cockpit with. So what we've got to do is develop the power electronics to convert the electricity as it's generated by this compact, lightweight, efficient electrical machine into stuff that we can use on the aircraft. And to do that, we need a suite of power electronics. And to do all of that, not only have we had to develop all of the equipment to do it, we've also had to develop the test facilities to be able to test the components as we produce them. So I know you're all very used to me talking about composites and gears and engines and aerodynamics and that sort of stuff. The truth is that without all of the software and without all of the electronic and electrical components, HX50 would just be an ornament. And so although this stuff is not natural stomping ground for aeronautical engineers, it's really, really important to what we're doing. We're now starting to amass quite a significant number of components for the wheeled undercarriage system. So we've got some of the mounting components, we've got the brake calipers, we've got the upper parts of the main undercarriage oleos, we've got the fork here for the nose wheel, we've got some stub axles over there. We've got plenty of anti-rotation links and scissor links and things lying around now as well. So all of these things are coming together really nicely. This is a batch of gears for the first 3 engine drivetrains and some of the components of the main rotor gearbox that have just come back from some of the inspection processes that are required as part of our 30-step process for manufacturing gears. There's the first nose wheel. Here's the first main wheel with a nice bit of hill bling in the center of it. And then with these main wheels, as you can imagine, on the back of them, we have to have a floating integrated brake disc as well. So the brake disc lives in there, caliper is retained in there. Okay, a quick update then in terms of the factory. As I reported last month, we'd been asked to do some additional noise assessments for the Cresswell site. This work has now been completed. As I think I mentioned last month, we've been using one of the UK's leading authorities on aircraft noise, a guy that looks after a lot of the big airports in the country. We've optimized our flight corridors, we've optimized our aircraft movements, and we're expecting the noise levels from that work to show that all of the impact is now below the level for which there's any measurable impact on human health. So we've put ourselves in the best possible position to get this planning permission awarded. So pleased with the progress on that front. And then in other news, it's been another strong month in terms of sales. We currently stand at 902 aircraft sales with 733 X's, 169 C's, and I think it's 62 countries. Ruben and Misha will update me when we talk in a moment. But sales remain to be extremely strong, and of course, every week when we demonstrate further progress and more major steps in the program, it brings more people in. So there's never been a better time to come and join what we're doing here.